Hello students, welcome all of you at AriserTalent. How are you all? I hope you are doing absolutely good. So, in our previous lecture, we have discussed about some of the numericals that is based on the series and parallel combination of the resistances, and we have also seen that how you will calculate the electricity bill at your home and the power rating of various devices. Now, in our today's lecture, we are going to discuss about new topic which is entirely a different topic that is known as Wittstone bridge. Now, what is Wittstone bridge? Wittstone bridge is actually the arrangement of 4 resistors in the form of a quadrilateral where the value of 3 resistance has been given, and what you have to find? You have to find the value of unknown resistance here. So, what is the basic purpose of Wittstone bridge here? Wittstone bridge is generally used to calculate the unknown resistance. अगर हमें कोई unknown resistance calculate करना होगा तो हम क्या use करेंगे? We will use Wittstone bridge. So let's start the topic here. Wittstone bridge. So firstly, it is an arrangement of the 4 resistors in which 3 resistors are of a given value are provided and there will be always a unknown resistor, and these will actually arranged in the form of a quadrilateral. So firstly, Wittstone bridge, it is an arrangement of 4 resistances in the shape of a quadrilateral. Where 3 resistances are given and value of unknown resistance have to be found. So this is about the definition of Wittstone bridge, that what actually the Wittstone bridge is. Now let us see a diagrammatic representation here, so you will be very clear that what is the Wittstone bridge and how you will calculate the unknown resistance for the system. So Wittstone bridge Now, this is actually a circuit diagram of Wittstone bridge. Now, you can see that there is an arrangement of 4 resistors in the form of a quadrilateral. This is the quadrilateral we have, and we are arranging the 4 resistors here. So, what will be the value of resistors here? As I am mentioning, this is our R1, this is our R2, this is R3, and this is R4. So, what we have taken here? We have taken a 4 resistors in the shape of a quadrilateral here. Now, you can see from this diagram that R1 and R2 are in series and R3 and R4 are again in series, and this combination is connected in parallel with each other. We have used a battery. A battery is having a EMF of E, small e value, and we have used a key here. This key is actually our key 1. So, this is a battery we have. So, here the battery is having a voltage V volt, and this is our key 1. Now, in this section, what we have done, we have just attached a key 2 and the galvanometer here. What we are using? We are using galvanometer here and another key, that is K2, attached to the system. So, this is our galvanometer, and here I am using the second key. This is our K2. So, this is our K2 in this diagram. So, what we have used? We have used 4 resistances, and we have used 1 battery with a EMF E and voltage V, and we have used the 2 keys here, K1 and K2, and 1 galvanometer which will show the deflection when there will be the potential difference across any of the ends. Now, what I am doing here? I am just mentioning the corners of the bridge as A, B, C and D. What we have named here? A, B, C and D. We had given a name to all the corners of a quadrilateral. Now, this is a battery we have, and the current will start flowing from this. So, suppose the current I is going to flow from this circuit, and here in this bridge the current will be divided into 2 parts. It means the current that is going through R1 will be I1, and the current going to R3 will be I2. It means जब हम यहाँ से बैटरी जो बैटरी है हमारी, जैसे ही हम की को प्रेस करेंगे तो करंट स्टार्ट होना फ्लो होगा, एंड करंट यहाँ पर जाकर 2 ब्रांचेज में डिस्ट्रीब्यूट हो जाएगा, दैट इज I1 एंड I2. Now, this I1 is going to be flowed from this R2, and from this R4 again we have a current, that is I2. This is a deflection in the galvanometer we can observe. Now, this is the basic diagram for the Wittstone bridge that I have described here. Now, we have just do the naming of this diagram we have. This is a schematic representation of the Wittstone bridge we have. Now, firstly, we will discuss that on what principle this bridge is working and how we will find the unknown value of the resistance from here. So, firstly, let's discuss about the basic principle of Wittstone bridge. Now, let's discuss about the basic principle of the Wittstone bridge, but firstly, I am mentioning here that what are the components we have actually used in this bridge. So, what are the components we are using here? Now, you can see here we have used 4 resistors. How many resistors we are using? We are using 4 resistors in which this R1 and R2 are connected in series, and R3 and R4 are again connected in series, and these combinations are connected to each other with a parallel combination. So, firstly, I can write it here as we are using 4 resistors. There are 4 resistors. Among these 4 resistors, R1 and R2 are in series. R3 and R4 are again in series. And these both parts are connected to each other in a parallel form. So this is the arrangement of the resistors you can see here. Now we have used a battery here. This battery is having a EMF of E and two keys are used here, that is K1 and K2. So there is a battery of EMF capital E. We have used two keys K1 and K2. And lastly, what we have done, we have used a galvanometer which is going to show you a deflection whenever there is any changes in the circuit. So galvanometer is used to show the deflection. So these are the components we have used in the circuit we have described here. Now you can see that when this key is closed, whenever this key is closed, it means current I starts flowing in the circuit, and on this branch at the point A, the current is divided into two parts, I1 and I2. You can see that the current I1 will flow through the resistor R1 and R2, and this current I2 is going to flow from R3 and R4. So we can write here, when key 1 is closed, current I starts flowing and whenever this current starts flowing, what will happen at point A, it divides into two parts. And what are the two parts here? I1 and I2. It has the two parts, I1 and I2. So these are the two parts of the current we have, that in going from this wire, the current has been divided into two parts at this point, at this junction. Now, what is the basic principle involved in the working of the Wheatstone bridge? Let's check here, but firstly you have to copy these points from here, so it might be clear to you that what actual components we are using here. So just copy it from here so we can discuss the principle of the Wittstone bridge. Now, principle involved in the functioning of Wittstone bridge. Now, on what basic principle Wittstone bridge is working, let's understand here. Firstly, what we have seen that whenever the key is pressed, this key is closed, the current will start flowing from the circuit, and at the point A, current has been divided into the two branches. You can see that current I1 is flowing in resistor R1 and R3. So what we have seen here, current I1 is flowing in resistors R1 and R2. And you can see that current I2 is flowing in the resistor R3 and R4. Current I2 is flowing in resistors R3 and R4. So this is the schematic representation we have seen here, and what are the components we have taken. Now, what will happen in this circuit if the point B and D are having the same potential? It means if the B and D will have the same value, it means there will be no potential difference, and this galvanometer is said to be showing a zero deflection. अगर पॉइंट बी और डी का पोटेंशियल सेम है, सेम वैल्यू है, तो हम ये कह सकते हैं कि बी और डी के बीच में पोटेंशियल डिफरेंस कितना है? जीरो है. अगर पोटेंशियल डिफरेंस जीरो है तो गैल्वेनोमीटर क्या शो करेगा? जीरो डिफ्लेक्शन शो करेगा. तो हमें इसकी कंडीशंस ऐसे सेट करनी है कि गैल्वेनोमीटर क्या शो करे? जीरो डिफ्लेक्शन शो करे. अगर गैल्वेनोमीटर जीरो डिफ्लेक्शन शो करता है तो उस कंडीशन में हम ये बोलेंगे कि ये ब्रिज बैलेंस्ड है. It means this condition is known as the balanced bridge condition, and it is known as the null deflection. It means zero deflection the galvanometer is showing here. So the next point will be, if B and D have same values, अगर B और D की value same है, then potential difference is zero. And if potential difference is zero, galvanometer shows zero deflection, or we can say it as a null deflection. And when the galvanometer is not showing any deflection here, if there is no deflection in the galvanometer, we can say that this bridge is balanced. So we can say that the bridge is balanced. So this is actually the principle we are using in the Wittstone bridge, that the bridge, this bridge should be balanced here, and this will be balanced only when the galvanometer shows no deflection. Now let us calculate the expressions for the Wittstone bridge from the components we are using here. So now we will derive an expression for I1, R2, R1, R2, R3, R4 and I1 and I2 that we are using in this circuit. So firstly, copy this principle from here. Now let us have an expression for this Wittstone bridge we have. What we have seen until now, we have seen that the bridge is said to be balanced when there is a zero deflection in the galvanometer, and this is known as the balanced bridge condition and the null deflection condition. Now, this is our point A, this is our point B, this point is C and this point is D. If I am writing here the first condition we have, the first condition is VA minus VB will be equal to VB minus VC. It means the potential difference across the ends A and B will be equal to the subtraction of the potential difference from B and C. So this is the first condition we have. Now, according to this condition, I can also write here I1 R1 is equal to I1 R2. You can see the this adjacent arms of the bridge. These are the two adjacent arms of the bridge, and we can write here I1 R1, that is equal to the voltage, because from the Ohm's law we have a general formula V equal to IR. I1 R1 will be equal to I1 R2. So I1 R1 is equal to I2 R2. This is the first condition we are getting here. Now, look at the other half part of the bridge. This is the other half part we have. Now, what you can see here, VA minus VD will be equal to VD minus VC. This is the difference in the potential. So, I can write here VA minus VD will be equal to VD minus VC. This is the condition for voltage, and the current flowing in the resistors R3 and R4 can be written as I2 R3 equal to I2 R4. So, the next condition is I2 R3 equal to I2 R4. This is our I1 R2. This is our I1 R2. So, this is the second condition I am getting from the lower half part of the bridge, that is I2 R3 will be equal to I2 R4. So, you can see that here we are getting the two equations from this formula. I1 R1 equal to I1 R2 and I2 R3 will be equal to I2 R4. Now, we have to derive the expression for the resistances here, because what we have to do, we have to just calculate the value of the unknown resistance here. So, let's do the further calculation here. We will calculate the potentials between these bridge, so we can derive the expression for the resistances here. So, the conditions here for the calculation of the resistance will be, you can see here, these are the two arms of the bridge. These are the two arms of the bridge, and the voltage difference between these two arms will be the same. So, I can write here VA minus VB will be equal to VA minus VD. So, the first condition I am getting here will be VA minus VB equal to VA minus VD. A और B का potential difference A और D के potential difference के equal होगा. Now, according to Ohm's law, we know that V equal to IR. So, the current flowing in this arm is I1 and the resistance is R1. So, we can write I1 R1 equal to I2 R3. So, the next condition is I1 R1 equal to I2 R3. This is our equation number 1. Now, look at the other half part of the bridge. What you can observe here, in this bridge, VB minus VC will be equal to VD minus VC. So, I can write here VB minus VC equal to VD minus VC. Now, the current flowing in the arm BC and CD will be I1 R2 and I2 R4. So, I can write here I1 R2 and I2 R4. So, this is the second equation I am getting here. This is our second condition. What you have to do, you have to just equate the voltages in both the arms. The voltage here will be I1 R1 equal to I2 R3. The voltage in this arm is I1 R2, which is equal to I2 R4. Now, we are getting two equations here. On dividing both the equations, what we will get here? So, I am writing here on dividing equation 1 and 2. These are the two equations here. I1 R1 upon I1 R2 is equal to I2 R3 upon I2 R4. These are the two equations we are dividing. Divide left hand side by left hand side and right hand side by right hand side. What you will get here, I1 cancelled by I1, I2 cancelled by I2. And I am getting here R1 upon R2 equal to R3 upon R4. So, this is the condition of resistances we have derived here, and in this condition, when R1 upon R2 equal to R3 upon R4, we can say that the bridge is balanced. So, in this condition, the bridge is said to be balanced. So from this equation, you can find out the value of the unknown resistances, but what you have to do, you have to just set the values of these 4 resistances, so the galvanometer always show the 0 deflection. We have to choose the some constant values here, that the galvanometer always shows 0 deflection. Suppose in all these 4 resistances, I am considering here, this is our unknown resistance. This is our unknown resistance. Now, from this formula, how you will find the value of unknown resistance? Just shifting that equation, we can found that R4 equal to R2 into R3 upon R1. So this is the formula. You can find the unknown resistance of a circuit just by cross multiplying R2 by R3 and dividing it by the R1. So you can see from this concept that Wittstone bridge having the 4 resistances arranged in this manner is actually used to find the value of the unknown resistance in the circuit. So this is again very important topic, and you can find the value of unknown resistance from this formula. So copy this concept from here, so we can proceed to the next part. So now this is all about the Wittstone bridge we have discussed here. So let's do one numerical problem on the Wittstone bridge, so it may be clear to you that how the questions will be asked in your exam. So what you have given here, find the current through 36 volt battery in the given circuit. So what you have given a 36 volt battery and you have given a circuit. Now this circuit can be redrawn like in the form of the Wittstone bridge, because from this circuit you cannot just identify whether they are in series or parallel. So we have to draw a circuit which containing the Wittstone bridge here. So let's redraw the circuit. Firstly, what we will do? We will redraw the circuit. So you can see here, there is a 36 volt battery connected to the 5 ohm resistance. So what I will do here, I will just draw the circuit it like as, this is a resistance and this is our 36 volt battery. This is a battery of 36 volt along with the resistor of 5 ohm. Now I am drawing the Wittstone bridge here. So this is our circuit for Wittstone bridge, and I can write it here. This is point A, this is point B, this is point C, and this is point D. This 5 ohm resistance is connected with a 36 volt battery, and what about the other resistances? You can just see from here. You can see that this is a 4 ohm resistance. So this 4 ohm resistance is lying between 2 ohm and 2 ohm here. This is lying between 2 ohm and 2 ohm. So this is our 2 ohm, this is again our 2 ohm, and this is present between the system like this. This is our 4 ohm. Now what we are left with? We are left with one more resistance, that is 6 ohm and 6 ohm. So this 6 ohm and 6 ohm is lying in the other half part of the battery, and this system is connected between them. So I can write it here. This is our 6 ohm and this is again our 6 ohm. So you can redraw the circuit in the simplified form from the Wittstone bridge like this. Now what you have to find? You have to find the value of current through the 6 volt battery. Suppose from this battery, if the current I is flowing, what you have to do? We have to just find the value of that current. Now from Ohm's law, we know that V equal to IR. This is the formula we have. So from this formula, I can write here, if I want to calculate the value of current, I equal to V upon R. So we will use this formula for calculating the value of current in the circuit. Now voltage we have given is 36 volt, but firstly you have to find the equivalent resistance of the circuit. Now you can see here these two resistances are connected in series. 2 and 6 are in series, 2 and 6 are in series. So what I have to do here, firstly we have to calculate the R equivalent. So this R equivalent will give you these two in series, so it came out to be 2 plus 6 equal to 8 ohm. Again these are in series, so we can get here again 2 plus 6 equal to 8 ohm. Now this series combination and this series combination are in parallel with each other. So we can write R equivalent as 1 upon 8 plus 1 upon 8, and it came out to be 2 upon 8, and the value of R equivalent will be 8 upon 2, that is equal to 4 ohm. So you can see that how I will calculate the value of 4 ohm here. These two in series, these two in series. Again these series combinations are in the parallel with each other. So for the parallel combination 1 upon 8 plus 1 upon 8, and I am getting here 4 ohm. Now we can draw one more circuit like this. So what we will get in the simplified circuit, let's see here. This is our 5 ohm, this is our battery, and for the combination of this I am getting here 4 ohm. 4 ohm, 5 ohm, 36 volt. This is the simplified circuit I am getting from Wittstone bridge. Now you can see that 5 ohm and 4 ohm are in series connection with each other. So we can calculate here R total will be 4 ohm plus 5 ohm, and it came out to be 9 ohm because these two are in series again, and the voltage here we have is 36 volt. So on substituting both these equations or both these values in the Ohm's law, what I am getting here, voltage is 36 and resistance is 4 ohm. So 36 divided by 4 will give you 9 ampere current. So the current flowing in the circuit is equal to 9 ampere. So you can see that how the problems on the Wittstone bridge can be simplified in a very easier manner. So if you are given any complex circuit, just draw the Wittstone bridge circuit of that. After analyzing all the resistances, just do a simplified diagram and calculate the value of any unknown quantity with the help of the Ohm's law. So this is all about the Wittstone bridge we have. Copy this solution from here, so it may be very easy to you to understand this concept. So this lecture is over for today. We will deal with many more lectures on our next session. Thank you so much and have a nice day.